we looked at how bias kind of comes about when we have graphs, right? We looked at some interesting examples that I think were kind of tricky, things that we see all the time on like social media and magazines and things like that. So we talked about how bias happens in graphs, but we also realized that bias can also happen when we're doing a survey. So not just how we represent data, but how we actually collect it. We talked about how there were certain types of bias. And the first type of bias that we went over was this thing called voluntary response bias. And well, to explain what it is, it's literally in the name, right? Voluntary response bias happens when we ask people to respond to a sample. And we said that was really bad because, well, the only people who really respond to a voluntary response sample are people who have really negative opinions or really positive opinions. Usually the people in the middle don't want to respond. Now they are asked to respond, they just choose not to. So that was kind of the whole idea of voluntary response bias. But there's two other types of bias, so why don't we go over these? Next, we have this thing called self-interest bias. Now, it's literally in the name. It's whenever we're doing bias on purpose to benefit ourselves, okay? And the best idea that I can come up with to demonstrate what self-interest bias is are commercials like these. I don't know if you've seen a commercial like this before. This usually happens when like a lot of like toilet paper brands use this technique where they just throw random numbers on their toilet paper wrappers, paper towels usually do this. Even dish soap uses this, and there's this brand called Fairy. I don't even think this is a real brand, but they literally have this thing where they say they did the sample and they said, okay, 1 bottle of Fairy equals 2 bottles of the generic brand, right? Well, this doesn't really help us learn anything because it doesn't even tell us what they're comparing, right? It just says 1 bottle equals 2 bottles. That doesn't really do anything. Yeah, so this is an example of something called self-interest bias because the company is doing this in their own interest, right? This only really benefits the company, and they're just making up things that compare it to a different company in order to benefit themselves. So that's kind of the whole idea of self-interest bias. You'll usually see this in advertisements for people trying to make themselves look better. Any questions on self-interest bias?
So what would they consider doing advertisement on top of what like to better themselves with this product? What would they try to consider like that would make them look better?
I think it would make more people like want to buy it, I guess. I think that's kind of the whole idea about it. Like if I said, statistically, my class is more fun than all the rest of the other classes. Now, that is a true statement, but it is in my self-interest, right? All right. Any other questions on self-interest bias? All right, let's go down to the last type of bias. This one is a little bit tricky because I think you can get it mixed up with a different type of bias. This one's called non-response bias, and it's literally in the name. It happens when you have this big portion of the population that doesn't participate. Now, I was going to ask you something for this. Let's say I give out this survey and I ask you, how many of you have murdered someone at 4 p.m. yesterday? Well, do you think anyone's going to respond to that? No, everyone's going to either say no or like not answer, right? So this happens a lot when there's like a question about illegal activity that people don't really want to answer, right? So a lot of, or a big portion of the population or a big important part of the population isn't going to respond. Another idea is I could give out a survey through a phone call, okay? If I phone a bunch of people and ask them, do you like cell phones? Well, who's not going to respond to that? Yeah. People don't have a cell phone, right? If you don't have a cell phone, you literally can't respond to the survey because you weren't even asked the question, okay? So the idea behind non-response bias are usually when, well, you have a really badly constructed survey. So you send out a survey with a method that some people like literally don't even have the choice to respond. Or people don't have the choice to respond because, well, you're asking them something that they literally can't answer without like going to jail or something like that. Okay, so the whole thing behind non-response bias is there's a big portion of the population that literally can't give you an answer.
Okay, so
Mhm.
would this be sort of like a setup? Would you say?
With the illegal activities, I feel like people wouldn't respond because they think it might be a setup. It might not be a setup, but well, someone who, I don't know, committed a crime at 4 p.m. yesterday is probably not going to respond because, well, they might think it is a setup.
Yeah.
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 All right. Any questions on non-response bias? Okay. Now, before the test, the past couple semesters, I always got this question because there's two types of biases here that are really, really similar, okay? There's non-response bias, where people don't respond, and there's also voluntary response bias where, well, there's a problem because some people also don't respond to that one. Can someone describe the difference between these two? Nika?
A voluntary response is more so people choosing not to respond, because it's just like a general question that they don't feel like answering. Non-response bias means people most of the time literally can't answer it.
Perfect. That's literally what I was going to say, right? So what Nico said is when we have voluntary response bias, people aren't responding, but it's literally people who choose not to respond because they have an average opinion. Okay, so with voluntary response bias, people choose not to respond. Okay, now on the other hand, we have non-response bias where there are people who don't respond, but those people literally don't have the choice, right? They either didn't get the survey question or, well, they can't answer because they're being asked about something that would maybe get them in trouble if they told it to the wrong person, right? So this one, people don't have the choice. Oh my, I did it again, Popple. People don't have the choice. So they don't respond. Okay, so that's kind of the difference between voluntary response and non-response. They are very similar to each other, and I think there's a question on the homework where either one could have been the answer. So I'll leave that up to you. As long as you have a good description of why you think it might be voluntary response or non-response or even self-interest, these questions get a little bit debatable. So if you have a good reason, even if it's not what I think, I'll probably mark your question correct if you have a good description of why you think that way. Okay, any question on bias? All righty. So what we're gonna do is if you flip your page over, we're kind of going away from this idea of bias and going towards a little bit more of vocabulary that I'm going to be saying a lot during the next 14 weeks of this class. And the first two that I'm going to talk about are things that describe things that describe numbers that you'll see. Okay, so this is a math class. There are going to be a lot of numbers in this class, and there's two types of numbers. Okay, now before I talk about these two types of numbers, let's just go back to sampling. When we do a sample, we take a small sample out of a large population, right? So we have those two words floating around. If you see a number in this class and it describes a sample, we call it a statistic, okay? So S for statistic and sample. If a number describes a population, we call it a parameter, okay? So P for parameter and population. Now, on the homework and probably on a test, I am required to ask you, okay, I'm going to give you a number and be like, okay, is this a statistic or is it a parameter? These questions get a little bit tricky because when you read these questions, it's kind of hard to tell if something's actually describing a sample or a population, especially if you don't know the whole idea behind the sample or the situation that's going on. So here's what I'm going to do. I'm going to make a deal with you. Anytime I give you a question that involves statistics versus parameters, I'm going to make it very obvious that a number is coming from a sample or if it's not coming from a sample. And the way I'm going to do that is if you see the word in a sample, or another way to see sample is like I polled someone. So I asked people questions and polled them. If you see either of those two words, the number is going to be a statistic. Okay, so if You see those two words, statistic. If it doesn't say that, well, it's going to be a parameter. Okay, so these questions do get really tricky. I think looking for those two buzzwords really help you understand, okay, that's a statistic or that's not a statistic. Let's do a few examples. All right, 57% of the teachers at Central High School are female. We're going to focus on this number 57%. Who thinks this is a statistic? Who thinks it's a parameter? All right, anyone who raised their hand on parameter want to explain why? Some hands, Melanie?
It doesn't include anything about like being a sample or being pulled.
Yeah, right. So if you look at this question, it doesn't say the word sample, right? So it doesn't say that we sampled anyone. It also doesn't say that we polled anyone, right? So those two words on in it, this question has to represent a population because we're not talking about a sample. So this has to be a parameter. All right. Any questions on number one?
Oh, so as long as it doesn't say, in a sample.
Yep.
Or some people were pulled or something like that.
Yep. It's got to be a parameter, right? Perfect. All right, this one is number two. We have a sample of 100 surgery patients. We're not going to focus on 100 because that's just the number of things that there are in the sample. They were given a new pain reliever. 78% of them reported significant pain relief. Who thinks this is a statistic? All right, we got almost all the hands up. Anyone want to explain why it's a statistic? Raven?
Because it mentions in a sample.
Yeah, right. It literally says in a sample, this number describes the sample. So this has to be a statistic. All right, so I try to make this a little bit easy for everyone. These questions do get a little bit crazy. So I think if you look for those two buzzwords, it's very obvious that something's a statistic versus a parameter here. Any questions on statistic versus parameter? All right. If we flip our page over, I'm going to introduce some more words that I throw around in this class. These are all words that you've probably heard before, but I just want to make sure that we know the difference between them. Let's say I had a sample and I collected a bunch of information. That information is data, right? So a bunch of data that we collect, okay? Now, the people or things that we collect the data from are called individuals, right? So they're individuals in my sample. And well, we collect information about groups called variables, right? So variables comes from the word vary, and things that vary can change, right? So things that change are called variables. All right, so in this example, we have a bunch of students with their majors, their exam scores, what grade they have in their classes. Who are the individuals here? Students, right? They're the people that we want to collect information about. So the students definitely have to be the individuals here. What are the variables? Perfect, right? Wait, there's actually 3 variables in this example. We're not just collecting the information about the majors, we're also collecting the exam scores and their grades. And these are the things that change depending on the student. So let me put this down. We got major, we got exam score. We also have the grades. I'm going to call those things variables. Okay, let's focus on student number 1. What's the data for student 1? Perfect, a psychology major. All right, what else? Perfect, they got a 92 on their exam. And what's the last piece of data for that student? Yeah, perfect, got an A for the class. All right, that's what I like to see in this class. All right, so I think we're pretty good with these definitions. Just kind of want to make it clear. So when I talk about these words, they're not like, oh, well, what's the difference between the two? All right, let's keep moving on. The next type of thing are 2 words that I am going to be throwing around all the time throughout the semester. These 2 words are things that kind of just get thrown around all the time, and they're very similar to each other, so it kind of gets like confusing if you look at them a little bit too hard. So when we do a survey, there's many different types of questions that we can ask, right? So there's many different types of data that we can get. And there's actually like a way to separate these two types of data, okay? The first type we're gonna call qualitative, okay? And qualitative variables are things that can be put into categories. These are usually things that are verbal. So the answer to the question is always going to be a word and not a number. So I'm gonna put verbal here. Okay, and the word qualitative actually like makes this pretty apparent, right? When I ask about the quality of something, you're always going to answer with a word, right? If I ask you, what's the quality of this desk? You're not going to be like 5, right? Usually you're like, oh, it looks pretty sturdy, right? So that's the whole idea of qualitative. Just a little note, I might be using the word categorical to describe qualitative. A lot of, I think our textbook uses the word categorical. I like qualitative better though. Now, on the other hand, quantitative, when I ask the quantity of something, you're always going to respond with a number, right? So quantitative are always numerical, okay? So numerical answers, okay? Now, another word for quantitative that you might see in some textbooks is the term measurement data. So don't worry if you see measurement or categorical, all they mean is qualitative and quantitative. So qualitative, verbal, quantitative, you answer with a number. All right, here we have some examples. These also can be kind of debatable, but usually people think of like a very specific thing. So let's go with this one. A person's age. Who thinks this is qualitative? All right, who thinks it's quantitative? I saw. All right, anyone who said quantitative want to explain? Gabrielle? It's a number, right? Once you ask for someone's age, the person's usually going to be like, oh, I'm 5 years old, or oh, I'm 20 years old, something like that. So this is definitely quantitative, right? All right, next one, I wore my cat dress for this. The breed of cat you own, who thinks this is qualitative? Yes, because, well, you answer with a word, right? You don't be like, oh, what type of cat do you have? And someone's like, 4. I have the 4 type of cat. No, we say qualitative. All right, mileage, who thinks qualitative? Quantitative?
Quantitative.
Quantitative, yeah. And these words get a little bit hard to say after a while. And then finally, if someone asks, what's the color of your car? Are you gonna quantitative? Qualitative. Qualitative. Now, some people who are really into cars might say like the actual number of the color. So I don't know if anyone wants to say that, but usually people respond with a word for the color of things. So I'm going to say qualitative. Okay. Any questions on the difference between quantitative and qualitative?
Did you say it the same way? Qualitative.
Qualitative. I just say that because I know they all start with qua. So I just say qua, and then in my brain, I have to figure out which one is it. Is it qualitative or quantitative? All right. Is that the end of the notes for this section? All right. Then I guess what we can do is we can get a little head start on the next set of notes. I have these printed out, so I'm just going to go ahead and pass these out. All right, so we did a little bit of a slow start to the semester. There is a lot of math in this class. We're going to kind of ease into the math in this section, and then we'll get a little bit more mathy after this one too. But okay, so in chapter 30.1, or you don't have the textbook, so it doesn't really matter. We're going to talk about not just like the differences between the types of data, but actually how to display them. So how to create graphs, how to make charts, things like that with data as well. At the top, I expected myself to start a class with this. We just went over the 2 types of data. There's qualitative and there's quantitative, right? So there's qualitative. I'm just going to put qual and quant. Okay. In this specific section, 30.1, we're going to focus on the qualitative. So things that can be described with words as opposed to numbers. So that's why it's called representing categorical data, because qualitative is also known as categorical. Okay. So I think we've seen all these types of graphs before, but it's actually kind of interesting how to make the second type of graph that we talk about. First of all, we can represent things with a bar graph or a bar chart or a circle graph or a pie chart, right? So let's just go over how we go about doing these. Let's say we have a retailer. They accept 4 types of credit cards. We have all the data up here. And before we come up with like a bar graph or a pie chart or something like that, what I like to do is create a frequency distribution. You've probably heard this as a tally chart, right? To represent, well, how many of each type are here? Okay, so I'm gonna give you a little bit. How many times do you see MasterCard up here? 11. I know you count really fast. I agree with 11. Anyone else? Sometimes my notes are wrong too, so. All right, we all got 11. Perfect. All right, now there's a lot of Visa on here. How many Visas are here? 23. You are really fat. Honestly, it took me a while to do this on my notes. All right, let's keep going. How many American Express? There's 9. Perfect. That's what I got too. And how many Discover are there? 7. Perfect. All right, so you can count this at home, but I think we can all agree that these are the number of observations of each type. Now, before we go on, if you take a look at like the number of observations here, if I didn't tell you that there were 50 observations in the question, how would you be able to find out the total number of observations? You could add up the number of observations, right? Since this is a tally chart of like every single thing that there is, well, they have to add up to how many total that there are. So if I just add down 11 plus 23 plus 9 plus 7, I can tell you that my total is going to be 50, even if I didn't tell you in the question. Okay. Yeah, so that's why tally charts are pretty interesting, because you can just find the total without being told. All right, so why don't we go to this next example where we actually have to make a bar chart or a bar graph. I know you've seen these before, but why don't we just go over the basics of doing this? All right, so when we do a bar graph, we have to have an X and Y axis, right? So why don't we draw those in? I'm kind of cheating because I'm using my iPad and it makes really straight lines. So mine might look a little bit better than yours on paper. But I'm gonna make my Y axis or my vertical axis. I'm gonna make my X axis or my horizontal axis, okay? What variable is gonna go on the X or horizontal axis? Is it gonna be the type of credit card or is it gonna be the number of times I see it? Mhm. Yeah, because that's the thing that we're looking for, right? The number of times something occurs always goes on the y-axis. So the x-axis is really going to represent the type of credit card. The y-axis is going to represent the frequency or the amount of times that we see it. So frequency. Okay. Now, one thing that statisticians love harping on in statistics are very minor details. Whenever we make a bar graph with categorical data, so when we're dealing with qualitative data that can be expressed in words, we have to have a space between the bars. That's just how math is. They're very picky about this. So what I'm gonna do is I'm gonna like start with maybe the 3rd bar here. That's gonna represent MasterCard, okay? I'm gonna leave a little space, so I'm gonna go like 1, 2, 3, 4 over, and that will be my Visa, okay? We've also got, oh gosh, we've got American Express. And then we finally have Discover. Okay, so they're very widely spaced apart. All right. Now the y-axis is representing frequency, so we have to fit all the counts that we did here. What do you think I should count by on the y-axis? Could do that, but what's the highest number of observations that I have to have on the y-axis? Yeah, I've got to get up to 23. I don't think there's 23 blocks. So what do you think I should count by? I could. Let's see, 2, 4, 6, 8, 10. That's not what I was thinking, but let's try it. 14, 16, 18, 20. Oh, that's true. Let's do by twos. All right, so let's do 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. Perfect. All right. Then I guess we have to make our MasterCard slot. MasterCard, we said, was 11, right? So I'm gonna make a little mark at 11. I'm gonna start with MasterCard, go all the way up to in between 10 and 12, make a line there. And I usually just kind of extend my line down to make the first bar. Okay, now some people get really artistic with this. I kind of just scribble it in. Then Visa is 23, right? So we can do the same thing with Visa. Okay. Fill that in. Okay. I keep saying AE and I want to say American Eagle, but it's not American Eagle, it's American Express. American Express was, what was it, 11? Yeah. And then finally Discover was 7, right? So we can make a little chart for that. Okay. Now I know this was pretty simple. The biggest thing, oh yeah.
American Express is 9.
Oh, it was 9. Thanks. I got a little bit lazy. I didn't want to check my notes. There we go. Thanks, Lauren. All right. Now, I know this is kind of self-explanatory. The reason I had you do this is because when you make a bar graph, it's really important to first at least figure out like what the tick marks on the X and Y axis are going to represent, right? So that's really important. And the biggest part about a bar graph is you have to have spaces between the bars. Okay, so I'm going to write that down actually. Must have spaces between the bars. Okay, now, oh yeah. Yeah, I was actually just about to ask that. Does anyone know like why spaces between the bars with qualitative data are important? It does make it more readable. We'll actually see another graph that doesn't have spaces between the bars. And I'll give you a hint that, well, when we deal with quantitative data, yes, there won't be any spaces between the bars. Any idea on why like qualitative data needs to have spaces other than, well, it makes it more readable? Well, they're not connected, right? I think the whole point is MasterCard, Visa, American Express, Discover, these are things that aren't connected at all. So if you make the bars touch, it almost makes it seem like MasterCard like flows into Visa and Visa flows into American Express and American Express flows into Discover. And that's kind of the reason why mathematicians are like, no spaces between the bars. That is not how qualitative data should be expressed, because well, we don't want to like make it seem like there's some sort of connection between the two. When we move into quantitative data, you'll actually see how like one bar will flow into the next, and then that bar will flow into the next. And it'll be a little bit more obvious when we do an example, but for qualitative data, make sure you have the spaces between the bars. All right. Any questions before we move on to pie charts? All right, pie charts are a little bit more interesting. I think we've all known how to make a bar graph even before this class, but let's just talk about how we go about making a pie chart. Pie charts are really interesting because it's not just like figuring out how many things there are. So we're not just tallying things up. We actually have to understand what the angle is in the pie chart is going to be, right? So there's little angles that we have to calculate. well, let's, gosh, what was I gonna talk about? It's not the hypotenuse, no. Let's just talk about the proportion of observations, for example, before we do this. Whenever we talk about some sort of chart and we're looking at the frequency that things happen, we can also think about not just the frequency, but the proportion of times it happens. So maybe the percentage of times you see MasterCard, or the percentage of times you see Visa and things like that. Now, we get that by dividing what we're interested in by the total, right? So that kind of gives us the proportion of things that there are. If that's confusing, then just wait till we do an example. But that's not the angle in the pie chart, right? The proportion of things that things happen isn't the angle that you have in the circle. Now, before I tell you about the angle or how we actually calculate that, does anyone know the total number of angles in degrees that there are in a circle? 360, right? Now, this is embarrassing, but I actually didn't I found it hard to memorize 360. Like, for some reason that wasn't sticking in my head. The thing that made this stick in my head was there's this song called, I don't know if you watch the videos, but it says, did a whole 180. And then the person like flips around and then they do a whole 180 and they flip around again. If you do two 180s, you go all the way in the circle, right? So that's how I memorized that 360 degrees are in a circle. So total number of angles in a circle is 360. And now you'll have that song stuck in your head for the rest of your day. Okay. Now, if we want to find the angle on a pie chart, what we're going to do is we're going to take the proportion of times you see like Visa or MasterCard or something like that, and just multiply it by 360. So just multiply that proportion by 360, and you've got the angle on your pie chart. Yeah, not too bad. Let's do an example. All right, going back to MasterCard, Visa, American Express, things like that. Okay. Well, we already calculated the number of observations. Now, can someone remind me how to find the total number of observations again? Oh, for the angle in the pie chart, but I'm asking for like the total number of observations. Yeah, you add 11, 23, 9, and 7, so we know that the total is 50. Okay, can someone tell me how to find the proportion of observations of MasterCard? So how do we do the proportion of times that we see MasterCard here?
It would be 11 divided by 50.
Good, right? Because 11 is the number of times we see MasterCard, and then we divide it by the total, right? So we always divide what we're interested in by the total. Okay, now you can do this in your calculator. I got 0.22. Okay. All right, Visa, you do the same thing, right? So if I wanted to find the proportion of Visa, I'm going to take what I'm interested in, which is 23 this time. And what am I dividing it by? 50, perfect. So when you do that in your calculator, I got 0.46. All right. Can someone quickly find the decimal for American Express? 0.18, perfect. And then what's the decimal for Discover? 0.14, good, right? So everyone clear on how to find the proportions of observations here?
So it's the number of observations divided by total.
Perfect, great. All right, so that's the proportion of observations. Now, this doesn't have anything to do with making a pie chart. These numbers aren't going to help us because these aren't the angles inside the pie. So what we actually have to do is go in and actually calculate the angle in the pie chart. Why don't we go ahead and do that? What am I going to multiply to get the angle of MasterCard? Perfect, 0.22 times 360, because, well, that's what the formula said, right? You take the proportion and you multiply it by the angle. So when we do this, I got 79.2. Okay, so that's the angle inside that MasterCard slot. What about Visa? What would I multiply?
0.46 times 360.
Perfect, 0.46 times 360. When I multiply that together, I got 165.6. Okay, can someone tell me what the angle for American Express is? Okay,
360,
and what number does that become?
64.8.
64.8, everyone agree with that? All right, and can someone tell me the number for discover?
50.4.
50.4, perfect. Okay, so these are gonna be the angles inside the pie chart. Any questions on how to get these angles? Okay, now we would actually do the circle thing, but I forgot to bring in my protractors today. So let's just skip to the next question and we'll go back to actually creating the pie chart on Monday. If you flip the page, we have another example very similar to your homework. We have results on a survey of my friends' favorite types of movies. How would I give you a couple minutes to work on this? You can work together if you'd like, or by yourself if that's what you would like this Friday. Why don't you spend a little bit of time just filling out the chart and we'll come back in a little bit. All right, let me get situated here. So here we have a different type of thing going on. I got Sean to write up the proportion of observations here. Sean, do you kind of just want to take us through how you got the proportions?
Yeah, just divide the number of observations by the total.
Perfect, right? And how did we get the total, by the way?
Setting the number of observations.
Yeah, right. If you add down, you'll get the total. All right. Any questions on the proportions?
Wait. Oh, did we do the same sort of thing with the angle?
We didn't do the angles yet.
Oh,
Yeah.
okay.
All right. And Gabrielle, do you kind of want to explain how you got the angles?
Yeah, I did the proportion of observation.
Perfect, right? So you just took these, multiplied them by 360, and we got these three numbers here. All right. Any questions on example 2? Yeah.
40 and 40 is like the same thing or?
Oh, so 0.40 versus just 40. Yeah, these two are different, right? Because when you write 40, there's actually a decimal point after the 0. It's just like not really written, right? So with every number, there's actually a decimal point like right after the number. Yeah, so these two are different numbers.
Because I think we moved the decimal point because there was a 0 there. I don't know if that
Oh,
is the same thing or not. but-
no, these look right.
Oh, yeah, no, I was like, I think I wrote mine, just like put the 0 point or.
Oh, did you get 0.4 then?
0.1.
Like that?
Yeah.
Oh yeah, if you got 0.4, that's totally fine. So it doesn't matter how many zeros you write after a decimal like value. I could make this 0.4000 and it'd still be the same number. Yeah.
Oh,
Yeah.
this is
So yeah,
all-
don't get confused when you see that. Yeah.
Okay, because sometimes I get confused. I'm like, is that the same number?
Yeah, it looks a lot different, but they are the same. Yeah.
Okay.
All right. We do have a little bit of time left, so let's just go on to the next question here. By the way, I got a good question when we were filling out these. In class on Monday, we will do the full pie chart, so we'll go over how to actually draw one. They do require these things called protractors though. So since you guys don't have your own protractors, I'm never going to require you to like draw a pie chart with a protractor like on the homework or a test or something like that, because you just don't have the protractors. We will learn how to do it, but I don't expect you to know how to do it in the future. All right, let's do this example here. We have 1,200 students at a middle school, and we have a pie chart that kind of shows all the clubs and sports that they are involved in. Okay, so in this part A, it's asking us, okay, how many of these students participate in sports, right? So if you take a look at the pie chart, it looks like 38% are in sports. How would I figure out how many of the students actually do participate in sports? Unknown?
I did work on the 200 times 0.38.
Perfect. And how did you get 0.38?
In the pie chart, it says that there's like 30% that do sports, so I just
Mhm.
moved the decimal place like over 2 times to the left.
Yes.
So and then I just multiplied.
Perfect, right? So if you ever want to convert a percentage to a decimal, the easiest way to do it is to take the decimal point and just move it 2 places to the left. So 38% is really 0.38, okay? And then what Melanie did is, okay, I know the proportion of students that participate in sports. The total is 1,200. So I'm going to take 0.38, which is the proportion. I'm going to multiply it by 1,200, which is the total. Okay. And if you multiply this out, I got 456. So there are 456 students in total that participate in sport. Yeah, Shayla, to write up part B. Do you kind of just want to go through how you got your answer?
25% decimal place.
Mhm.
is 0.25, the total
Perfect. So 300 students participate in clubs. All right. Any questions on how to interpret a pie chart? All right, now we did a little bit more math today than Monday and Wednesday. I think I'm gonna kind of just end it here. I think this is a good spot to end class. So I hope you have a great weekend. I will see you on Monday.